Neurons are the building block of the nervous system that transmit information through the body. Dendrites receive information from other neurons and sensory receptors. The nucleus provides energy for the neuron to carry out its functions. The cell body contains the nucleus. The axon carries the neuron's messages to other body areas. The myelin sheath covers the axon. It increases neuron communication, and deterioration of it can cause multiple sclerosis. Schwann cells are non-neural cells that generate myelin. The axon terminal forms junctions with other cells. Action potential is a neural impulse that brings a brief electrical charge down the axon. It brings positively charged atoms that move in and out of the channels in the axon's membrane. The action potential travels from anywhere from 2 to 200 miles per hour. In resting potential, polarization occurs. The inside of the neuron has a slightly negative charge and positive ions surrounding it. Depolarization occurs when the message begins and sodium ions come in to depolarize a section of the axon. During refractory period, potassium ions are pushed back out and the neuron pauses to reload. The synapse is the junction between the axon tip of the sending neuron and the dendrite or cell body of the receiving neuron. Reuptake is the effect of turning the volume down on messages being transmitted between neurons. This keeps messages from being sent again. Acetylcholine helps in learning, memory, and muscle contraction. It is associated with Alzheimer's disease. Dopamine's roles are movement, thought process, and rewarding sensations. Dopamine is associated with Parkinson's disease, schizophrenia, and drug addiction. Serotonin helps with emotional states and sleep. It is associated with depression. Norepinephrine helps in physical arousal, learning, and memory. It is associated with depression and stress. GABA neurotransmitters' primary role is inhibition of brain activity. It is associated with anxiety disorders. Lastly, endorphins control pain perception and positive emotions. Endorphins are associated with opiate addiction. Agonists mimic neurotransmitters and produce the same effects as the neurotransmitter it is mimicking. Antagonists are similar enough to neurotransmitter receptor sites to block messages, but they do not stimulate any activity. The blood-brain barrier enables the brain to fence out unwanted chemicals circulating in the blood. The nervous system consists of neurons that control thinking, feeling, and acting. The spinal cord connects the peripheral nervous system to the brain. The brain receives information, interprets it, and then decides a response. Sensory neurons carry information from sense receptors to the central nervous system. Interneurons are messengers between the two neurons within the central nervous system. They are located in the spine and brain. Motor nerves carry outgoing messages from the central nervous system to the muscle glands. The nervous system consists of all the nerve cells. It is the body's speedy electrochemical communication system. The central nervous system is located in the center of the body and contains the brain and spinal cord. The spinal cord transmits the messages between the brain, which is the body's control center, and the rest of the body. The peripheral nervous system is the sensory and motor neurons that connect the central nervous system to the rest of the body. This divides into the autonomic and the somatic nervous system. The somatic nervous system controls voluntary movements, such as raising your arm or leg. The autonomic nervous system controls involuntary functions like heartbeat, breathing, and digestion. The autonomic nervous system divides into the sympathetic and parasympathetic nervous systems. The sympathetic nervous system arouses the body and prepares it to act in stressful situations. The parasympathetic nervous system calms the body and conserves energy to keep a constant internal state. The endocrine system puts hormones into the bloodstream. The cerebral cortex is responsible for sophisticated information processing. Animals do not have a cerebral cortex, only humans do. The frontal lobe of the brain controls movement, higher order thought, and the production of speech. The parietal lobe contains the somatosensory cortex to sense things like touch. The occipital lobe controls vision. And the temporal lobe controls hearing and interpreting and understanding language. Broca's area controls the motor function of speaking. Wernicke's area interprets the words and puts meaning to them. The left hemisphere of the brain controls language and logic. The right hemisphere is visual, spatial, and creative. The right side of the brain controls the left side of the body, and the left side of the brain controls the right side of the body. The hypothalamus controls hunger, thirst, and sex drive. The thalamus processes sensory information to the cerebral cortex. This does not include smell. The hippocampus processes new memories. The amygdala controls emotions and forms memories from them. The medulla controls autonomic functions like breathing, heartbeat, and digestion. Pons controls facial expressions and the sleep cycle. The cerebellum controls motor functions and balance. Reticular formation controls arousal during sleep and helps you become alert when you wake up. The pituitary gland regulates growth and controls endocrine glands. The hypothalamus, pituitary gland, amygdala, and hippocampus make up the limbic system.